One way to help us to understand electric circuits is to compare a simple electric circuit like this with a water circuit. Now, at the bottom we've got the voltaic cell. We remember that the long stripe is the positive terminal of the cell, and the short stubby bit is the negative terminal. Okay, and when I close this switch, an electrical current will flow around the circuit and will always flow from positive to negative. Now, the positive terminal has the high electrical potential, and the negative terminal by default is always the low electrical potential, which is 0 volts. Now, if we look at the water circuit, well, you can see here we've got two reservoirs, one at the top, one is higher than the other. So the water in this reservoir has a high, now it's not an electrical potential this time, but it's a gravitational potential energy. So we would say it has a high GPE, while the lower reservoir has a low GPE. Now, as soon as I open this tap, well, then we know that water will flow, and it will flow always from the high GPE to the low GPE, as in the same way that the charge in this electrical circuit will flow from a high electrical potential through to the low electrical potential. Now, if we just open this tap and let the water flow, it will just keep flowing, and it will flow down and down, down, and there it will stay. If we want the water to come back up to the high reservoir again, then we have to use some kind of pump in order to do that. Otherwise, the water will remain at a low GPE. So we can say that the pump in this circuit, in this water circuit, plays a similar role to the voltaic cell in this circuit. So in the sense as we've got an electrical pump here lifting water up to the higher reservoir so that the water can continually flow around the circuit, well, inside this voltaic cell we've got a chemical reaction taking place between two electrodes which is lifting charge from, at this terminal, from a low electrical potential to a high electrical potential. The voltaic cell acts a little bit like a type of chemical pump. We can also talk about the electrical potential difference. So if I increase this electrical potential, for example by adding more voltaic cells one after another, or rather than using an AA battery I go for a 9-volt battery, for example, then I will increase the flow of charge around the circuit. Charge will flow faster around this circuit as a result. Well, similarly, if I increase the gravitational potential energy of this reservoir by making it higher so that there is a greater gravitational potential difference, then I will increase the flow of water around this circuit in a similar way. So we can now complete this table of comparisons. For example, the cable which connects the components in an electric circuit is equivalent to the tube, okay, which connects the reservoirs and the motor in the water circuit, tube or pipe. And the charge, that's the stuff that's flowing really in the electrical circuit. So these are electrons, little particles called electrons, which are flowing around the metal conductor, while in the water circuit it's the water that's flowing, so the charge is equivalent to the water. Now, the current in an electrical circuit is really the flow, or the rate of flow of charge. It tells you how much charge flows in a given unit of time, that's to say per second. Well, in the water circuit then it's the flow of water, it's the rate of flow of water around the circuit is equivalent to the electrical current. Now, as we said earlier, the electrical potential is analogous to the gravitational potential in the water circuit. We would use the symbols E, P, E, electrical potential energy, and G, P, E, for the gravitational potential energy. Now, what actually pushes the charge around the electrical circuit is not the electrical potential, but it is the electrical potential difference. It is the difference in potential energy between one terminal and the other which is important, and likewise it is the difference in gravitational potential energy that causes the water to flow. There has to be a difference in height for this water circuit to work. I'm going to abbreviate that: gravitational potential difference. And finally, well, the battery in the electrical circuit is analogous to a pump in the water circuit. That's to say, the pump raises water from a low gravitational potential to a high gravitational potential. Well, the voltaic cell or battery does the same thing. It raises charge from a low electrical potential at 0 volts to a high electrical potential at the positive terminal. So let's make a note of that. That's the pump in the water circuit. And finally, well, the switch in the electrical circuit is clearly analogous to the tap in the water circuit.